So we are here to learn how to write the formula of ionic compounds. To write the formula of ionic compounds, we must need to know the formula of the ions, positive ions and negative ions. If we know the formula of positive and negative ions, then we can write their name and we can make the formula of ionic compounds. For example, a positive ion is sodium ion and a negative ion is oxide ion. And the formula of oxide ion is O2 minus. So name of the ionic compound would be sodium oxide. It would be sodium oxide. All right, sodium oxide. Now, what would be the formula of sodium oxide? Look at that sodium, the symbol is Na. Please write Na here. And the symbol for oxide ion, it is O mainly. Write O here. Now you can see that there is 2 minus as the power. It indicates the charge of oxide ion. The oxide ion is negative, that's why it is minus. And it has gained, the oxygen atom gained 2 electrons, that's why 2 minus. Now these 2 would come here in the place between sodium and oxygen, but this 2 will be like this in the lower case. So Na2O, and sodium has plus, only plus means 1 plus, only plus means it is 1 plus. So sodium 1 would be coming here, but 1 is unnecessary to write or mention. So do not write 1. So sodium oxide is Na2O. Let's see another one. For example, sodium ion, and it is Na plus. And for example here, hydroxide ion. And hydroxide ion is OH minus. You have to remember the formula of positive and negative ions. I will be giving some positive and negative ions list here today. And there are some positive and negative ions formula also given in your textbook. So you can memorize them or you can just remember them, anything. But I think that if you understand how to form positive and negative ions, how many electrons a positive ion that an atom donates or leaves or gives to form a positive ion, and how many electrons an atom gains to form negative ions. If you understand this concept, that would be better. So name of ionic compound, and sodium and hydroxide ion, when they form together, it forms sodium hydroxide definitely. So writing name is very simple, sodium hydroxide. And the formula would be N, you first write Na, then you write OH. Now you interchange 1, 1. Sodium has 1 plus. Only just plus means 1 plus. So sodium has 1. And hydroxide is only minus means 1, 1 minus. So 1, 1. You interchange 1 and 1. So I said before that 1 is not necessary to mention. So sodium hydroxide is NaOH. Now I continue with sodium ion again. Look at this sodium ion, and for example now here I want to change a bit. It's carbonate ion. Carbonate ion. Okay, so the formula of carbonate ion is CO3 2 minus, like this. We have to be very sure about CO3, where to write 3. Look at this, where to write 3 and where to write 2 minus. 2 minus is the charge of carbonate ion. So it would be sodium carbonate. Writing, I said that just writing name is very simple, sodium carbonate. So I made a color with them so that you can understand that that is the title. Okay, sodium carbonate. Now, sodium carbonate, just first our duty is to write Na, and the carbonate is CO3. This is your first duty, write Na for sodium and write CO3 for carbonate. Now, look at the CO3, it should be like this. Now, interchange the numbers. Sodium has 1 plus, so put 1 after carbonate, and I said you that 1 is not necessary to write. And carbonate has CO3 2 minus. Look at this, 2 minus. I mention, I repeat, 2 minus. So why is there, ignore the minus, just put the 2 here after sodium. Interchange. Charge of sodium would go to carbonate after carbonate, and the charge of carbonate ion would come after sodium. So Na2CO3. And ignore the plus minus. Now this is the formula of ionic compound. So this is about like sodium ion. If I do the same sodium ion with another ion, for example, phosphate ion. Phosphate ion is PO4 3 minus. How about this one like this? So it would be sodium phosphate. So just write sodium Na and just write PO4 at first. This is our first duty. Now interchange. Phosphate has 3 minus, so the 3 would become after sodium. Here we go. And sodium has 1 plus, just 1 comes here. 1 is not necessary to write. Again, now sodium ion and sulfide ion. Now, so you have to, I repeat, you have to memorize or you have to remember the formula of ions. If you do not know the ions, what is the formula of ions, then you cannot write the ionic compounds formula. It's very important to know the formula of ions. Now, sodium ion and sulfide ion. Sulfide ion is As2 minus. Sodium sulfide would be sodium, and just first of all write sulfide, sodium sulfide. Now at first you write Na and you write S, then 1 after S, and sulfide ion has 2 minus charge, so 2 after sodium. Interchange, remember, I repeat many times, interchange. The charges interchange. Again sodium ion, and here CHLORID, chloride ion, Cl minus, and it would be sodium. Look at this 1 charge, sodium chloride, NaCl. So it is NaCl. Sodium has 1, chloride has 1. Ignore the signs, plus or minus, ignore it while writing the formulas. So sodium 1, it comes after chlorine or chloride ion, and chloride ion has 1 minus. The 1 comes after sodium ion. So 1 is, ones are not necessary to mention, so they're gone. 1, we never write 1 during the writing of formula of ionic compound. We never write 1. All right, sodium ion, and how many ions left? Sodium ion, for example, sulfate ion, SO4 2 minus,
Bangladesh legendary player.
and here you have to write first of all sodium sulfate, so it would be Na. At first you write Na, then you write SO4. SO4, 4 must be like this. And so NaSO4, sodium sulfate, Now look at the charges. Sodium has 1 plus and sulfate ion, it has 2 minus. Interchange, 2 of sulfate ion comes here after sodium, and sodium has, look at this here, sodium has 1 plus on top, right? So 1 comes after sulfate, 1 is not necessary to mention. So NO2SO4. So this is with sodium ion. There are more negative ions. Chloride, we wrote already chloride ion, bromide ion, fluoride ion. We can write hydrogen carbonate ion. You want to see hydrogen carbonate ion? Hydrogen carbonate ion looks like this. Hydrogen carbonate, it looks like HCO3 minus. This minus is like this as power, and this is like this as lowercase letter. So HCO3 minus is the hydrogen carbonate ion, and sodium hydrogen carbonate. Sodium hydrogen carbonate is the name. Writing the name of the ionic compound is very simple. Just add the words of the positive and negative ions names, and you get it as ionic compound's name. And formula of ionic compounds will be, let's first of all you write Na, then you write HCO3. All right, all this 3, definitely it will be like this. Now look at this, both have charges of 1 and 1. Sodium has +1 and hydrogen carbonate, it has 1 minus. So 1 1, you know that 1 is not necessary to mention. There are a lot of, there are more negative ions, definitely. Nitrate ion, you can consider nitrate ion. Nitrate ion, and nitrate ion is NO3 minus. These are simple really. So it would be sodium nitrate. All right, sodium nitrate, sodium nitrate, and it is NaNO3. Now you know how it is NaNO3. If I make another one, if I add one more negative ion, then it would be, there would be 10 formulas regarding sodium ion. What we can add more? Nitrate, phosphate, hydrogen carbonate, hydroxide, chloride, bromide. Bromide we can add, it's a common one. We can add bromide ion. We can add bromide ion. Bromide, BROMID, bromide, minus. Okay. So formula name, sodium bromide, and it will be NaBr. Okay, very simple. So get a screenshot so that I can move forward. Now look at this. If instead of sodium ion, if I change it with another ion, for example, I want to change an ion that has +2 charge, for example, magnesium ion. For example, magnesium ion. Magnesium ion has charge of Mg2 plus. So this one, and negative ions are these, all these negative ions. I'll just make a copy here. Look at this, all these are copied already. Very simple. Okay, so magnesium, first of all, up to this we finished. I make a color so that you can understand. This is a different color, means these are all sodium. And now I'm going to solve magnesium. I want to give a different color so that you can easily follow it, or it can easily attract your eyesights. this is magnesium. Okay, all right. Now look at this. We have finished sodium ion. Now magnesium ion and oxide ion. Please follow with me where I am right now. Magnesium ion and oxide ion. Magnesium oxide. Definitely magnesium oxide. And the formula will be Mg. At first you write magnesium Mg and then you write O. So now they have 2 plus and 2 minus. So magnesium 2 is here and oxygen 2 is here. Both are 2, 2. So when you see both are 2, 2, both are 3, 3, both are 4, 4, similar charges, then we don't need to write these similar charges. So ignore these 2 and 2. They omit each other, they cancel each other, and just MgO. So magnesium oxide, it has charge of MgO. Now look at this, magnesium hydroxide. Magnesium hydroxide. It's magnesium ion and hydroxide ion. So first write magnesium, then write OH. The magnesium has 2 plus, the 2 of magnesium is here. Here we go. And oxide hydroxide has 1 minus, so 1 is not necessary to mention. But this way we cannot leave it because this 2, it looks like this 2 is only with the hydrogen. Here the hydrogen, it looks like, it seems like that this 2 is only with the hydrogen, but this 2 is not only with the hydrogen. This 2 is with hydroxide. That's why I put a bracket here. Hydroxide contains 2 atoms. Hydroxide ion contains 2 atoms, oxygen and hydrogen. Now magnesium carbonate. Look at magnesium carbonate. Magnesium carbonate. So it would be MgCO3. Look at this, 2 minus and 2 plus, they cancel each other. Magnesium phosphate now. Magnesium phosphate. Mg, at first you write Mg, then you write PO4. Now we interchange. Phosphate has 3 minus, so put a 3 here. And look at this, phosphate has more than 1 atom. So magnesium 2 would be here, but with the bracket. Because in phosphate, there is phosphorus, there is oxygen. Magnesium sulfide. Magnesium sulfide, it would be MgS. Two cancel each other. Magnesium chloride. Mg2. So magnesium sulfate. Now it becomes easy for you to write. Magnesium sulfate is MgSO4. This 4 is like this in lowercase letter. Magnesium and hydrogen carbonate. Magnesium hydrogen carbonate, and MgHCO3. So magnesium has 2, that 2 is here in lowercase, and hydrogen carbonate has 1 minus charge, and that is not necessary to mention here. And do not forget to interchange the charges. Magnesium nitrate. Magnesium nitrate, it is MgNO3. Put a bracket here. Bracket here is magnesium bromide. Remember MgBr2. Br represents only one atom, bromine. Br represents only one atom, bromine. That's why there is no bracket. But NO represents 2 atoms, N for nitrogen, O for oxygen in nitrate ion. That's why there is a bracket. HCO3 represents 3 atoms, H for hydrogen, C for carbon, O for oxide and oxygen. So 3 atoms, that's why there must be a bracket. But Br represents only 1 atom, bromine. That's why there is no bracket here. So these are some formulas between positive and negative ion like this. I give you some extra things to practice. If you practice them, will be much more efficient. So I invite you to do this work at your home by yourself. You can do by using aluminum ion. Microsoft Word does not know aluminum ion, right? That's why there's a red mark. Aluminum ion is like this. So now I solve one for you, like aluminum carbonate. How aluminum carbonate? What would be Al? Then write CO3. So this tree is like this. Put carbonate ion into bracket. Now carbonate ion has charge of 2 minus and aluminum has 3 plus. So 2 of carbonate would be here and 3 of aluminum would be here. All right. So remaining, you just do the practice by yourself. I can give you some more. So these are some positive. This is the style to form positive and negative ion. Here you have got some negative ions, and I can give you some other positive ions. For example, lithium ion. It is Li plus. Iron has two ions. Iron has one is 2 plus, another one is iron 3 plus. So you can do these positive ions and those negative ions to form many compounds, and you can just make the formula of different ionic compounds.